Hi guys, welcome back to my video on triangles. So I want to start off this video by going over a few definitions. So an altitude of a triangle is a segment joining the vertex of a triangle to the opposite side and perpendicular to the opposite side. A median is a segment joining a vertex of a triangle to the midpoint of its opposite side. A median divides a segment into two congruent segments. And then we have the bisectors. So to bisect is to divide into two congruent parts. Angles or segments. And an angle bisector is a segment or ray that splits an angle to two congruent angles. So to visualize this, if we look at this triangle ABC, if we draw a segment that joins a vertex of a triangle and that's perpendicular to the opposite side. I didn't draw it here, but this is a right angle. We have an altitude segment AH, right? And a segment that joins a vertex of a triangle to the midpoint of the opposite side. AM is a median, and M is the midpoint because, that's how it's going to divide this segment into two congruent parts. So segment MB is congruent to segment MC. I want to go over circles. A circle is a set of all points that are equally distant from a point called the center. And a radius is a segment joining the circle to its center. So an important thing to remember for this for congruences is that the radii, the plural of radius of the same circle, are congruent. So if we look at this figure here, we know that OA is a radius and OB is a radius because they join the center to the outside circle. And therefore these two things are going to be congruent, right? Segment OA is congruent to segment OB. Okay, so let's do some problem solving. So here we have a triangle AB, D, and C is kind of like, doesn't necessarily have to be in between, but it's just a point on BD. We're given the angle 1 is congruent to angle 2, and that segment AC is an altitude, and we want to prove that AC is also a median. So you write down what we're given, and since an altitude is perpendicular to the side which it is drawn, we know that segment AC is perpendicular to segment BD, and the angle ACD and angle ACB are right angles. And since right angles are congruent, angle ACB is congruent to angle ACD. We also know that segment AC is congruent to itself, and therefore by angle side angle postulate, triangle ACB is congruent to triangle ACD. So what's the angle? Angle is coming from 1. 1 is congruent to 2. The side is the fact that AC is congruent to AC, which is 6. And then the other angle is coming from these two right angles, which are congruent from statement 5. So angle, side, angle, and we have the congruence from that. Since we established the congruence of these two triangles, we can deduce that segment CB is congruent to segment CD. Corresponding parts of congruent triangles are congruent. So since these two segments are congruent, we know that point C is going to be the midpoint of segment BD. Why? Because a midpoint divides a segment into two congruent segments. And then finally we know that segment AC is a median. Why? Because the median joins a vertex of a triangle and the midpoint of its opposite side. We'll do a second problem here. So angle 1 is this angle outside here, and angle 2 is this angle outside here. So we're given that segment AB is congruent to segment AC and that segment AM is a median. And we want to prove that angle 1 is congruent to angle 2. So we write down our givens here. And since segment AM is a median, then point M is the midpoint of segment BC, because a median joins a vertex of a triangle with the midpoint of the opposite side, right? And since this is a midpoint, segment MB is congruent to segment MC, because the midpoint divides a segment into two congruent segments. We also know that segment AM is congruent to itself, which is the reflexive property of congruence, and therefore by side postulate, triangle AMB is congruent to triangle AMC. The first side is coming from one, segment AB is congruent to segment AC. The second side is coming from segment AM is congruent to itself, and the last one is coming from 4, which is segment MB is congruent to segment MC. So AB, AM, MB, AC, AM, MC, and we have these congruent triangles. And since they're congruent, the corresponding parts are going to be congruent as well. So angle MBA here is congruent to angle MCA here. So I know this is a straight line, so angle 1 is going to be supplementary to angle MBA, and in the same way, angle 2 is going to be supplementary to angle MCA. So since angle 1 and 2 are supplementary to congruent angles, we know that angles that are supplementary to congruent angles are also congruent. So angle 1 is congruent to angle 2. I want to do something with circles now. We have segment BA is congruent to segment CA, and we want to prove that angle B is congruent to angle C. So let's start off what we're given. We're given just this one thing, that segment BA is congruent to segment CA. But since we have a circle here, and O is the center, segment OB and segment OC are radii. And since they're both radii of the same circle, they're congruent. Why are they radii? Well, radius joins a point on the circle to the center of the circle. Actually, OA is also a radius, but we don't need that for this problem. We know that segment OA is congruent to itself. So using these three properties here, 1, 2, 3, by the side postulate, we know that triangle ABO is congruent to triangle ACO, and that angle B here is congruent to angle C because corresponding parts of congruent triangles are congruent. Let's do another circle problem. So we're given that AOB, so this angle outside here is congruent to angle AOD. And we want to prove that this ray CO bisects this angle BCD. So we write down what we're given, and we know that since this is a straight line, the measure of this angle plus the measure of angle 1 is going to be what? 180 degrees, so they're supplementary. Same thing for 2, if you add the measure of this plus the measure of AOD, you get 180 degrees. And since angle AOB is congruent to AOD, 1 is congruent to angle 2 because angles that are supplementary to congruent angles are congruent. We also know that since segment OB and segment OD are both radii of the same circle, these segments are going to be congruent because all radii of the same circles are congruent. We also know that segment OC, so OC is not a radius because point C is outside of the circle, right? But we can still say that segment OC is congruent to itself by the reflexive property of congruence. And then we can use side angle side with 5, which is segment OB is congruent to segment D. And then 4, which is angle 1, is congruent to angle 2. And then number 6, which is segment OC, is congruent to segment OC. So we have side, angle, side, side, angle, side. So we know that these BOC and a DOC are congruent, and therefore this angle is going to be congruent to this angle here. So angle BCO is going to be congruent to angle DCO. Corresponding parts of congruent triangles are congruent. And since these angles here are congruent, we know that bisecting an angle is dividing into two congruent parts. So this ray CO bisects angle BCD, because this ray splits the bigger angle into these two congruent angles. So this last problem is pretty challenging. If you want to go over it, it's fine. If you don't need to look it over. It's optional. And I don't want to discourage you guys too much by throwing something that's too hard. I don't know how hard it is for people who are watching this video, but it definitely involves a lot more steps than we're used to. So if you like to watch it, that's fine. I'm happy to go over it, and let's take a look at it. So we're given this triangle ABC, and we're given that segment AM is an altitude, and that segment AM is also a median, and we're given that angle 1, so angle 1 is this angle here, is complementary to angle C. And we want to prove that angle 2 is complementary to angle B. So let's start off with what we're given. We're given that segment AM is an altitude, it's a median, and that angle 1 is complementary to angle C. So because segment AM is an altitude, then segment AM is going to have to be perpendicular to segment BC, because an altitude is a segment that joins a vertex, in this case point A, to the opposite side, which is segment BC, and it's perpendicular to the side here, BC. So since the perpendicular segments meet at right angles, we know that angle AMB and angle AMC are both right angles, and since right angles are congruent, we know that angle AMB is congruent to angle AMC. We know that since segment AM is a median, M is the midpoint of segment BC, because the median joins the vertex with the midpoint of the opposite side. And since point M is a midpoint, segment MB is congruent to segment MC, because the midpoint divides a larger segment into two congruent segments. So now we can use the reflexive property of congruence. So segment AM is congruent to itself, and then we can derive by side angle side postulate that triangle BMA is congruent to triangle CMA, and then we use the fact that MB is congruent to MC, which is 8, and then the angle was this angle AMB is congruent to this angle AMC, and then 9, which was segment AM, is congruent to itself. So side, angle, side, side, angle, side. So we have something that's congruent. And since these two triangles are congruent, well, angle 1 corresponds to angle 2, right? And since they're both congruent triangles, angle 1 is going to be congruent to angle 2. Corresponding parts of congruent triangles are congruent. So what does congruence actually mean for an angle? Well, it means that the measures of the angles are equal, not congruent, equal, because the measure is a number, right? So we can write down that measure of angle 1 is equal to measure of angle 2. So in the same way, we from the fact that triangle BMA is congruent to triangle CMA, angle B is going to be congruent to angle C here, and therefore the measure of angle B is going to be equal to the measure of angle C. So we're given that angle 1 is complementary to C. So what does that mean? So if 1 is complementary to C, then the measure of angle 1 plus the measure of angle C is going to be equal to 90 degrees, right? But we know that measure 1 is equal to measure 2, right? So we can substitute measure 1 with measure 2, right? And then we know that measure C is equal to measure B, right? So if you add these two things, if you look at it, if you just substitute it, you would get measure 2 plus measure B of angle 2 plus measure of angle B is equal to 90 degrees by substitution. And that's the definition of complementary, right? So angle 2 is complementary to angle B. So this is a tougher problem. Most of it's coming from the fact that there's a lot of steps, and we had to kind of use this little trick at the end here, what congruence actually means. So definitely something that's challenging. I think you can probably condense some of these steps here so it won't be as difficult to follow, but I wrote it out in as much detail as possible to for you guys to understand what's going on. So I hope you enjoyed this video. I will definitely make some more, and I want to thank you guys for watching, and hope to see you in my next video. All right, have a good night, guys. Bye.